junior CMA aspirants from South India. As you all already know, Akash Agarwal Classes has launched for you all 100% English lectures in English for CMA Foundation students giving their examination in December 2025 and onwards. So here I am going to tell you how do you enroll in the batch. You just have to join our WhatsApp community, which is given in the link. Fill up the Google form again given in the link, and do download our mobile application Akash Agarwal Classes to access the notes. You all know the lectures which we are going to conduct will be 100% covered. There would be no subject which we are not taking care of. So we are going to take care of each and every subject, each and every concept. We are going to take MCQs for you. We are going to provide test papers. We are going to take live mentee sessions as well. Lectures which we are going to take for you all are 100% recorded lectures and not dubbed lectures. And you all know we have exclusive team ready for you all to teach you for your CMA Foundation December 2025 attempt for subject wise as well. And we are uploading the lectures on a weekly basis. All the important links which will be useful to you all are uploaded in the description box. Since we have many students who have cleared CMA examination at all the levels from Akash Agarwal Classes, and to reciprocate the love which we have received from South Indian students, we are here for you all taking lectures 100% in English, so that we can clear your CMA Foundation December 25 attempt together. So keep studying, do watch all the lectures till the end, and do show some love by liking the video, subscribing to the channel, and putting up a word in the comment box. Keep studying. Bye-bye.
Hello my dear students, hello. Welcome back to another video. Welcome back to another lecture of our correlation and regression. Yeah, so this is the second part of your correlation, and hopefully you have watched the first part. I would request everyone, if you have not watched the first part, go to the first part first. Watch the lecture number 1 first before watching the lecture number 2, because lecture number 1 is going to be the important part, and if you have not watched the lecture number 1, it would be a bit difficult for you to understand the lecture number 2. So that's the reason to watch the lecture number 1 first. And yes, if you are new to the channel, do subscribe to our channel Akash Agarwal Classes. Do subscribe to our channel Akash Agarwal Classes, and do share with all your friends, because Akash Agarwal Classes has started its 100% English batch for CMA Foundation, and we are providing you with the lectures which are recorded and not dubbed, which are recorded in 100% English form, and there are going to be many more updates from our side. So do subscribe to our channel, and if you are not joined our WhatsApp community, we have created a WhatsApp community. The link of the WhatsApp community is available in the description. So also do join that WhatsApp community to get the latest update. As you all know, the lectures are going to be updated on the weekly basis. So as soon as the lectures are updated or uploaded on the YouTube, you will get the link of that lectures. So to get the link on the right time without wasting any kind of your time, you could just subscribe to the community or join the WhatsApp community and get the latest update as soon as possible. So let's start to the main topic. Let's get back to our main topic. In the yesterday's lecture, in the previous lecture, we have started with the correlation. Then we saw there are 4 types of measures. One is scatter diagram, which we have studied. Now today we are going to study Karl Pearson, congruent deviation, and rank correlation coefficient. So first we saw scatter diagram. In that, the scatter diagram, there were total 8 types, if you remember: perfectly positive, perfect negative, fair positive, fairly negative, moderate positive, moderate negative, and then no relation. And then later on we studied covariance. There were two formulas for covariance. The one formula was summation of x minus x bar into y minus y bar upon n. The other formula was 1 upon n into summation of xy minus x bar into y bar, where x bar is summation of x upon n and y bar is summation y upon n. So you know this x bar and y bar. What is x bar and y bar? X bar is mean and y bar is also mean. Property, it is not affected by change of origin. What? Your covariance. Covariance is not affected by change of origin, whereas your variance is affected. Covariance is affected by change of scale. Your variance can be positive, negative, or a zero number, but it should be what? It should be a real number. Then now further we saw many examples for covariance as well. We saw one example for these for this kind of your example, this kind of your formula. Then later on we also solved an example for 1 upon n into summation of xy minus x bar into y bar's formula. We saw multiple, I guess 3 to 4 examples we have seen in covariance. And then we started studying properties of correlation. The correlation, the most important topic from this chapter. The covariance, the correlation is represented, denoted by R or Rxy or R in subscript x and y. Your R is always between minus and 1. Your R should always be between minus 1 and 1. R is never greater, R is never going to be less than minus 1 or greater than 1. So you have to remember R always lies between minus 1 and 1, including 1 and minus 1. Then now after that we saw that the coefficient of correlation is not affected by change of origin as well as change of scale. So it is not affected by both. It is neither affected by change of origin nor affected by change of scale. We have seen many examples also in the previous lectures. So now let's come to the main topic that we are going to study today is going to be your Carl Pearson. So the Carl Pearson's formula, the correlation, we are going to find correlation. Correlation means R by way of Carl Pearson, by the formula of Carl Pearson. For Carl Pearson, you need covariance. That's the reason I first taught you. The covariance and then the coefficient of correlation. So first we have to understand covariance, because in Carl Pearson we are going to need what? We are going to need covariance of x comma y. So the Carl Pearson's formula is R is equals to covariance of x comma y into standard deviation of x into standard deviation of y. Now all of us know what is standard deviation of x and what is standard deviation of y, because we have studied standard deviation in our CT and dispersion chapter. Specifically in dispersion, if you remember, we have studied what is standard deviation. This is a standard deviation signs, or sometimes we also say standard deviation to be SD, but most probably standard deviation is going to be denoted by this sign. So over here your Carl Pearson's formula becomes R into covariance of x comma y in upon standard deviation of x into standard deviation of y, where your standard deviation of x is going to be under root summation of x minus x bar square upon n, and standard deviation of y is going to be summation of y minus y bar upon n. Now we already know how to find summation standard deviation of x, but for all those students who have not watched the center tendency and dispersion and directly coming to the correlation regression chapter, for those students I have given down the formula for standard deviation of x and standard deviation of y as well. So this is standard deviation of x and standard deviation of y, and the Carl Pearson's formula is what? Carl Pearson's formula is covariance of x comma y upon standard deviation of x into standard deviation of y. Okay, now let's see some of the examples of Carl Pearson. Let's see some of the examples of Carl Pearson so that we get an idea, we get to know how to solve the questions and how not. Okay, so here, now as I said, there are many formulas. One of the formula that we have written is covariance of x comma y upon standard deviation of x and standard deviation of y. And now we know that what is covariance. How do we find covariance? Covariance is summation of x minus x bar into y minus y bar upon n. So they have just written the covariances formula over here. Okay, now there is also a formula. There is also two more formulas to find. This is going to be one of the formula, n into summation of xy. So you could mark this or just note it down in your notebook. So this is going to be one of the formulas, n into summation of xy minus x bar into y bar. Now if you remember, this is also a formula. This is also the formula of what? Your covariance, if you remember. So summation of x minus x bar minus x bar into minus summation of x into summation of y upon under root n into x square minus summation of x square n into y square minus summation of y square. This is going to be one of the formula. There is one more formula, that is n into dx minus dy minus summation of dx into summation of dy, where dx is going to be x minus a. Now this kind of formula, sir, do this kind of formulas are asked in the exams? Yes, bacha log. What happens is, sometimes the data is given. Sometimes the data is going to be given. The question is going to give you summation of x minus x bar, summation of x, summation of y. They are going to give you n. Now what you have to do? Summation of x square, summation of x the whole square. That means summation of x square. So these all the data is given. And now when this kind of data is given, we cannot use the first formula over here. We cannot use the first formula over here because the data is inadequate for using the first formula. So at times when the formula is given, we have to use its respective formula. At time when the data is given, we have to use its respective formula. Sometimes they might give you what? Sometimes they might give you summation of dx into dy. Sometimes they might give you summation of dx. Sometimes they might give you summation of dy. Sometimes they might give you summation of dx square. So according to the data provided, we have to use the formula. So do we have to learn these other two formulas? Yes, you have to learn the other two formulas as well. When x bar and y bar are whole number and not in fraction, we can use summation of xy upon under root summation of x square into summation of y square. Again, this is going to be one more formula over here, formula number 4. So now let's come to the point, let's come to the questions that we could solve now. If the covariance between x and y is given 25, that means we have been provided with the covariance of x comma y. The covariance of x comma y is given 25. The variance of x and y are 36. So if you remember, variance of x is 36. Variance of y is given 25. So if you remember the relation between variance and standard deviation from chapter number your chapter number 2, that is central tendency dispersion. If you remember, there was a relation between variance of x and variance of y. Variance is, if you take square root of variance, it is standard deviation of x, and the standard deviation of x is what? 36 square root of 36, and square root of 36 is going to be 6. Similarly, standard deviation of y is going to be variance, root of variance of y, so it is going to be 5. It was 36, it is going to be 6. It was 25, it is going to be 5 over here. So covariance is given 25, variance is given 36, so standard deviation becomes 6. Standard deviation of y is given 25, so it becomes 5. So now they have asked me what? They have asked me coefficient of correlation. That means they are asking you R. Now the formula is covariance of x comma y upon standard deviation of x into standard deviation of y. This is 25 upon 6 into 5. Now which is going to be 25 upon 30, 0.8333. Now your R is going to be 0.8333. Is it greater than -1? Yes. Is it less than 1? Yes. So your R value should always be between -1 and 1. So the option number C over here is right. It is going to be very easy if you keep things simple. Keep simple things simple. Don't complicate it. If you complicate the things, it is going to be difficult for you. The things are very easy. The way of solving is very easy. It is totally formula based. If you know the formulas, you can solve it. Just give me a minute. Okay, let me connect the charger. Okay. Now, over here we have solved the first example. Let's see example number 2. The coefficient of correlation between x and y. So you know coefficient of correlation means covariance. So the covariance is given minus 16.5. Variance is 2.89. Variance of y is 100. So how to solve this? Let's see 2.89. This is variance. Let's take the root of it. It is 1.7. The standard deviation of x is 1.7. And hundreds is standard deviation of y is going to be 10. So how to solve this? 16.5 divided by 1.7 into 10. It is 17. So 16.5 divided by 17 becomes 0.9705, but in negative. So the answer is going to be minus 0.97. Minus 0.97, option number A. Option number A, minus 0.9705. Minus 0.9705. This is going to be your option number A over here. Example number 2. So the main thing we have to solve is when they have given variance, we need to find standard deviation. How do we find the standard deviation? By just taking the square root. By just taking the square root, because standard deviations square is what? Is variance, and variance's square root is what? Standard deviation. I have already taught this in central tendency dispersion. If the covariance between two variables is 20, if the covariance is given 20 and the variance of one variable is 16, so variance of x, let's assume it to be x, is 16. What would be the variance of other? Okay, they are asking me variance of y. So for this I need first standard deviation of x. So standard deviation of x is going to be 4. So how do we solve this? 20 upon standard deviation of x, that is 4, into standard deviation of y. So they are asking me what is the standard deviation of y. So if you see the options, your r, this is going to give you what? This is going to give you r. This is going to give you what? R. And now we all are aware that your r's value should be between minus 1 and 1. So if I assume my variance, if I assume more than 10, they are saying it to be more than 10. Okay, if I assume my variance to be more than 10, if I assume it to be 16 only, same, variance of x and variance of y are same. Let's assume it to be more than 10, that is 16. So if it is 16, this is the standard deviation of y is also going to be 4. So now this is going to be 20 upon 4 into 4, 16. So if we solve 20 upon 16, it is going to give you 1.25. But your r should not be what? Your r should not be greater than 1. So I cannot take my variance to be 16. So my more than 10 answer is wrong over here. So let's see more than 100. If I take my variance to be 100. Okay, if I take my variance to be 100, or let it be 121. If I take it 121, so what is going to be my 121's root? 11. And now this is going to be 4 into 11, 44. This is going to be 20 divided by 44. 20 divided by 44 is what? 0.4545. So my more than 10 is not going to work. But when I take more than 100, my answer is coming between 0.4545. So I can consider option number B. Let's see by taking option number C over here, 1.25. So more than 1.25 is going to be 4. If my variance is 4, my standard deviation of y is going to be 2. And this is going to be 20 divided by 4 into 2, 8. And then 20 divided by 8 is going to be 2.5. Again, my r is what? Greater than 1. So my option number C also goes over here. Less than 10, I can take less than 10 to be 9. If I take less than 10, my standard deviation of y is going to be 3. Now this is going to be 4 into 3 is 12. And then 20 divided by 12 is going to be 1.666. Again, my r is coming greater than 1. So my option number D also goes. So my option number B is right. When I take it to be more than 100, my variance should be what? More than 100. Then and then only my R's value to be less than 1 and greater than -1 is being satisfied. So option number B over here is right. I've taken what? More than 100. More than 100 I can take 121. If my variance of y is 121, my standard deviation of y is going to be 11. And once I take 20 upon 4 into 11 is 44. So 20 upon 44 is what? 0.45454545, which is less than 1 and greater than -1. That's the reason. If you use your brains, it is going to be very easy. Now let's see example number 4 over here. As I have already told you, if they are asking you other two formulas over here, the formula number 2 over here and the formula number 3 over here, they are going to give you data. They are going to give you whole data. Like see, over here they have given me summation of dx. They have given me dx square, dy square, summation of dx into dy, and dx is equals to x minus 69, dy is equals to, they have given me, and they are asking me to calculate the r's value. Now, if you take this formula, the formula is r is equals to n into summation of dx into summation of dx into dy. Summation of dx multiplied by summation of dy upon under root n into summation of dx square minus summation of dx the whole square multiplied by other root n into summation of dy square minus summation of dy the whole square. This is your formula. Now let's substitute. What is your n given? R is equals to n, they have given to be 8. They have given us summation of dx into dy. It is 2116. 8 into 2116 minus, they have given me summation of dx 47 into summation of dy, they have given me 108. Now they have given me n again, 8 into summation of dx square 1475 minus, they have given me summation of dx, right? What is the summation of dx? 47. So I can take 47 square into another root 8 into dy square 3468 minus, what is dy? 108 square. If you solve this now, it's going to be 2116 into 8, 16928 minus 47 into 108 is 5076 upon 8 into 1475 11800 minus 47 square is 2209. 8 into 3468 is 2744. Then 108 square is 11664. Now if we solve this, 16928 minus 5076 is 11852. 11,800 minus 2009, then we take the root, it is 97.9336 into 27744 minus 11664, and then the root is 126.806. We multiply it by 9336, then divided by 852. Your answer is 0.9543. So your R's value is 0.9543. Yeah, it is right. If you see over here as well, 0.95. Option number A is 0.95. So avoid this kind of questions. Give these kind of questions the last and the least priority of attending your paper, while attending your paper, time in your paper, because this is going to take a lot of time, and we cannot afford this much time, giving this much time for this particular kind of question. So try and understand, avoid this kind of question. Avoid means you can solve these questions, but give them what? Give them least and the last priority of solving these questions. So this is how we solve. Just it is, we have to learn the formula. If you have learned this formula, if you are aware about the formula, you can easily solve this, because if this kind of question is asked in the paper, the majority of the things are going to be given. So you have to just remember that thing. Now let's see one more question. Again, the same kind of a question. You can solve this in homework. All the things are given over here. Compute the correlation coefficient they are asking. You have to find the R, and majority of the things are given. They have given n to be 10, summation of xy to be 220, summation of x square to be 200, summation of y square to be 262, summation of x to be 40, summation of y to be 50. So you have to find what? You have to find the R. What is going to be the formula? The formula, I'll write down the formula as well. It is going to be n into summation of xy minus summation of x into summation of y. Again, it is going to come under root n into summation of x square minus summation of x the whole square, n into summation of y square minus summation of y the whole square. Now just substitute your given data, and then we can solve it easily. The correlation coefficient between, okay, they are asking me the coefficient of correlation between the observation is the first lecture. If you remember the first lecture and the first part that we have solved, correlation, coefficient of correlation between, they are asking me between the points given, right? So the points are, this is xy, this is xy, x comma y, x comma y, x comma y. So what are the points of x? Points of x are 1, 2, 3, 4, 5, 6, 7. 7, 6, 5, 4, 3, 2, 1. If you see, these numbers are increasing. If you see, these numbers are decreasing, and therefore there is a total negative relation, and negative relation is nothing but option number B, -1. Negative relation is nothing but option number B, -1. So hopefully the question number, example number 6 is also clear to everybody over here. Right? Okay. So what we will do is, let's let's come to the next part. Let's come to the next part. It is going to be your rank correlation coefficient. It is going to be your rank correlation coefficient. Rank correlation coefficient. And now this is the third type over here which we are seeing. Rank correlation coefficients formula is very easy formula, and there are very high chances they have asked many times in your paper for rank correlation coefficient. The formula is going to be 1 minus 6. This is not standard deviation, okay? This is number 6. 1 minus 6 summation of d square upon n cube minus n. Yes, the 6 is constant over here. 1 minus 6 is constant over here. 1 minus 6 into summation of d square upon n cube minus n. That's all. This is only the formula for your rank correlation coefficient. This is only the formula for your rank correlation coefficient. 1 minus 6 summation of d square upon n cube minus n. 1 minus 6 summation of d square upon n cube minus n. This is only the formula over here. Now, there is going to be a column of x. There is going to be a column of y. Your x be 10, 15, 12, 18, 25. Your y be 9, 14, 18, 20 and 25. So one is your x column, other is your y column. Now we are going to find ranks of x and ranks of y. We are going to find what? Ranks of x and ranks of y. So how to find rank of x? We have to find the highest number first, biggest number first. In the x column, which is the biggest number? 25 is the biggest number. So we'll give it the first rank. We'll give it the first rank. After 25, 18 is the second number. So this is going to be second rank. Then 15 is the number. It is going to be third rank. Then 12 and then 10. So the highest number will get the first rank, and subsequently the number becomes lesser, the rank also increases. After this, in the y section, 25 again it is the first rank, 20 is the second rank, 18 is the third rank, 14 is the fourth rank, and 9 is the fifth rank over here. Now we have ranks. I want D now. What is going to be D? D is going to be rank of x minus rank of y in mod. D is going to be difference in the ranks, rank of x minus rank of y. So 5 minus 5 is 0. 3 minus 4 is 1. 4 minus 3 is 1. 2 minus 2 is 0. This is also 0. Now if you see in the formula, I need n cube. I have n cube 1, 2, 3, 4, 5. There are total 5 observations. So n cubes become 125 minus 25. 6 is constant, 1 is constant. I just need summation of d square. I have found out d. Now I need what? I need d square. So 0 square is 0, 1 square is 1, 1 square is 1, 0 square is 0. This is going to be summation of d square. Summation of d square is 2. Summation of d square is going to be 2. Now my formula is what? Formula is 1 minus 6 summation of d square upon n cube minus n. So 1 minus 6 into d square is 2. N cube was what? N is 5. So 5 cube minus 5. So this is going to be 1 minus 12 upon 5's cube is 125 minus 5. So now if you solve this, 12 divided by 120 minus 1 gives you, this one is, always remember, this one is like this. The formula is going to be n cube minus n, or you will consider that one to be in the numerator place. No, n cube minus n. So yeah, once we solve this, this is going to be what? 1 divided by 20, and then we subtract it from minus 1. It becomes what? 0.95. $125. No, okay, my bad. So 1 minus 12 upon 120. 12 upon 120 is 0.1. So 1 minus 0.1 is 0.9. So answer over here is what? 0.9. For your rank correlation, answer is going to be 0.9 over here. Let's see some more questions for rank correlation coefficient. Yeah, Spearman's rank correlation coefficient, the exact name is going to be Spearman. As we mostly say to be rank correlation coefficient, but Spearman's rank correlation coefficient is the full name. Spearman was the person to invent, you could say, the rank correlation formula. So yeah, so let's solve a question again over here. Let's see what is going to be the answer. So yeah, x is given, y is given. Let's make a column of x. Let's make a column of y. X is 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Y is going to be 10, 7, 4, 8, 1, 3, 2, 5, 6, 9. Now we need a rank of x. We need what? Rank of x. Let's see the greatest number over here. The greatest number is going to be 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10th rank. And rank y. 10 is the first rank. 9 is the second rank. 8 is the third. 7 is the fourth. 6 is the fifth. 5th is the 6th rank. 4th is the 7th rank. 3rd is the 8th rank. 2nd and 10. Now we need what difference? So 10 minus 1 is 9. 9 minus 4 is going to be 5. 8 minus 7 is 1. 7 minus 3 is going to be 4. 6 minus 10 is going to be 4. Then 5 minus 8 is going to be 5 minus 8. As we know, this is going to be 6, 7, 8, 3. This is in the mod, so it won't be negative. You have to remember that thing. Then 9 minus 4 is 5. Then 6 minus 3 is 3. 5 minus 2 is 3. 1 minus 2 is 1. Let's see d square now. 9 square is 81. 5 square is 25. 1. 4 square is 16 and 16. 3 square is 9. 5 square is 25. 9 and 9 and 1. Let's find the summation now. 81 plus 25 plus 1 plus 16 plus 16 plus 9 plus 25 plus 9 plus 9 plus 1 is 192. So your d square is 192. Now let's solve How many n's are there? 10. So what is your r over here again? 1 minus 6 summation of d square upon n cube minus n. Last time I am writing the formula. 1 minus 6 into summation of d square is 192 upon n cube is 100 minus n is 10. Going to be 1 minus 192 into 6. 1152 upon 990. 1152 divided by 990 is 1.1636. Let me minus 1 from it. This is going to be 0.1636, and this is going to be negative 1.1 minus 1.1636. So it is going to be minus 0.1636, minus 0.1636, which can be written as minus 0.164. Option number A. Please note it down. Let's see, check, let's check. Yeah, minus 0.164, that's the right answer. So you could note it down. Hopefully, as I've already told you, if anybody is not writing it with me, but chalo, you have to write down it with me. Don't wait for me, you have to just write it down with me. Write down simultaneously rather than waiting. So yeah, you could pause the lecture and then write this. Pause the lecture, write this, take take the screenshot. Take the screenshot or pause the lecture over here. Okay. Now let's go to another example. Now let's see one more example over here. There is sales given and advertisement in thousands given. There is sales given and advertisement in thousand is given. Okay. Compute the coefficient of rank correlation between sales and advertisement from the following data. So again, there is X column and Y column. There is X column and Y column. Sales is given to be 190. This is 185. This is 168, 175, 182, 180, 195, 170. That's all. And Y 17, 16, 12, 13, 14, 15, 18, and 11. Now I will be solving summation of x and rank of x and rank of y. So rank of x, let's see the biggest number over here. Which is the biggest number? 195 is the first, 190 is second, 185 is the third, 182 is the fourth, 180 is the fifth, 170 is the sixth. No, 175 is the sixth. This is seventh. This is eighth. Then rank of y. Rank of y again, which one is the greatest number? 18 is the greatest. 17, 16, 15, 14, 13, 12, and then 11. This is the last. Let's find the difference. 2 minus 2 is 0, 3 minus 3 is 0, 8 minus 7 is 1, 6 minus 6 is 0, 4 minus 5 is 1, 5 minus 4 is 1, 0, 7 minus 8 is 1. D square is going to be 0, 0, 1, 0, 1, 1, 0, 1. Summation of D square is going to be 1, 2, 3, and 4. Now what is the formula again? 1 minus 6 into 4 divided by 8 cube minus 8. 1 minus 24 upon 8 क्यूब 512 मायनस 8 504 1 मायनस 24 डिवाइड बाय 504 0.0476 1 मायनस 0.476 is 0.8524 0.8524. Let's solve. Okay, 8 cube is going to be 512 and minus 8 is going to be 504. So this is 512 504. 24 divided by 504 is going to be 0.476 minus 195. Is going to be 0.95. Option number B. So next question, let's go to the next question over here. Yeah, if you just remember this thing, the 24 upon it is 510 rather than 506 rather than your 520. So I made a calculation error over there. Let's go to next question now. Let's see if I get some more question from the table. La, 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 la. Okay, let me see if I get any more questions. Let's solve one more question over here. This type of question is an important question. What happens in this kind of series if you see there's an x over here? Okay, this is only for understanding purpose. We don't have x and y for comparison. We cannot find d and everything. It is just to explain what if the in the rank situation. Okay, now you have to see over here. There's a x over here, and we're going to find rank of x now. So rank of x is like I have already taught you. The highest number is going to be the first rank. So highest number over here is 1. Then the next number is going to be the second rank. Now if you see over here, the second number over here. Okay, now this is going to be the first rank. And now if you see 19, there are twice. There is 19 twice over here. If you see, there is what? There is 19 twice times over here. So I cannot give this rank 2 and also this rank 2, right? I cannot give this rank 2 and rank 2 for both the situations. At that time, what I have to do is I have to keep see over here properly. Over here, what I'm going to do is I'm going to give this 2.5 and 2.5. I'm going to give what? 2.5 and 2.5. I give you more examples. Because if there were no repetition, this would have been 2 and 3. My two numbers would have gone, right? And now over here, what I'm going to do is I'm going to give this 2.5 and 2.5. After 1, I won't be giving 2. I'll give 2.5. I won't be giving 3 to the next number or 3.5 to the next number. I'll be giving 2.5 only. After 19, there is 17. I won't be giving 3 to it. I will give 4 to 17. Then 5 to 15, 6 to 14, and 7 to your 12 number. So when there is repetition, you have to understand. After 1, I am not giving 2, I am giving 2.5. And after 2.5, I am not giving 3, I am giving what? I am giving 4 over here. So my ranks are going to change when there are same observations. When there are same observations. Do I have to keep this thing in mind? Let's see if I get something else as well. Okay. In a bivariate distribution, if the rank correlation coefficient is given 0.12, so they have given us R. R is 0.12. Then they have given us summation of D square. Summation of D square is 146. And they are asking us what? They are asking us your N. They are asking us N. So what is the formula? If you remember the formula, R is 6 into 1 minus 6 summation D square upon N cube minus N. So your R is going to be 0.12. 1 minus 6 into, what is summation of D square? Summation of D square is 146. Now you need what? N cube minus N. You need what? N cube minus N. Now over here we can do is, we can just substitute and then solve it by your GBC method. You can solve it by GBC method. If I take option number at first, this is going to be 0.12. It should be equals to 1 minus 6 into 146. 6 into 146 is 876. And then I'm going to take 9 cube minus 9. So what is 9's cube? 9's cube is 729. 729 is going to be 9. So this is going to be 1 minus 876 upon 720. So 876 upon 720 is going to be 1.21. And then 1 minus 1.2166666. If I take, I get it to be minus 0.216. I get minus 0.216. But I need plus 0.12. I need what? Plus 0.12. That means option number A is wrong over here. Let's take option number D. Option number D is 10. So 0.12 is equals to 1 minus 876 is going to be as it is. 10's cube is going to be 1000. Minus 10, it is going to be 990. So 876 divided by 990 is going to be 0.8848. And then minus 1. It is going to be 0.115. It is going to be 0.115, which can be rounded up to 0.12. And that's the reason option D is going to be right. Option D, 10 is going to be right when I go by GBC. So this kind of question are going to be solved by GBC. I'll take N's value from the option, substitute in the N. If you don't know what is N, what is GBC, it is going to be go by choice. I'm just going to take the observation and substitute in my answer, substitute in my formula to get the answer. Let's go ahead and see if I get something else as well. Okay, so now this kind of questions are also asked in your paper. The coefficient of rank correlation of marks obtained by 10 students. So there are 10 students, that means your N is given to be 10. English and economics was found to be 0.5. So they have given us rank correlation was 0.5. Your R was 0.5. It was later discovered that the difference in the marks in two subjects obtained by one student was wrongly taken as 3 instead of 7. Then the correct coefficient of the rank correlation is okay. So if you see over here, there's given something. If you remember, there is going to be an X, there is going to be Y, right? For X is going to be subject of marks of English, marks of economics, mark of English, marks of economics, marks of English, marks of economics, marks of English, marks of economics of the students. And then we are going to find what? Then we are going to find difference, and then we are going to find difference, difference of basically the square of the difference, right? Then once it was discovered that the difference in the marks of two subjects was obtained by one student was wrongly taken. So there was a difference in the difference column. In the difference columns, we have taken wrong observation or wrong marks. One student has wrongly taken as 3 instead of 7. So, okay, we have taken the difference 3. But it was not supposed to be 3, it was supposed to be 7. So 3 is wrong. But if you understand or if you remember our formula, we don't add summation of D. Do we add summation of D? No, we add summation of D square. We add what? Summation of D square. So now this is not, we never took D square, that is 3's square. We never added 3, we added what? 3's square, 9. So rather than 9, rather than 9, now we need what? 7's square. 7 squares is what? 7 square is 49. So I don't need 9 over there, I need 49. So in the summation of D square, whatever the summation of D square is going to be, I need what? I am going to subtract 9 and I am going to add 49 over there. Okay, so now let's see. Hopefully the concept that I taught you or I tried to explain is clear. So R is 0.5, okay. Later discovered the correct correlation coefficient. Okay, they have given us this much only. So if you see rank correlation is given and incorrect. Okay, the correct is going to be D was incorrect and okay. So what is the formula over here? Formula is going to be 1 minus 6 into or 6 summation D square upon n cube minus n. So if you see over here, I have R is 0.5. 1 minus 6 into summation of D square. I don't have summation of D square. But I have n. N is going to be, n's cube is 1000 and 1000 minus 10 is 990. So this is going to be what? This is going to be, if you solve this one over here, okay, what I can do over here, let us see, 0.5 this is, if I take this one over here, let's try 0.5, the plus 1 over here becomes minus 1, this is going to be minus 6 summation of D square upon 990. Okay, so this is going to be minus 0.5, this 990 comes over here and becomes multiplied by 990, this remains minus 6 into summation of D square, this becomes minus 945, once I divide by 6, it becomes minus summation of D square, it becomes 82.5 is equals to summation of D square. So after calculating I got summation of D square to be 82.5. I have just substituted the things in the formula, then I have solved it, and then I kept summation of D square and took one thing at a time in the other side of the equal to. I get what? Summation of D square. Summation of D square is what? 82.5. Now I know there was some error in the summation of D square. It was what? Rather than 3. So this is summation of D square, right? And we have taken D to be 3. So I don't want D to be changed. I want D's square to be changed, that is 9. And instead of 9, I want it to be 49, that is 7's square. So instead of 9, I want what? 49. So I am going to just subtract 9 and add 49 in that. 82.7 minus 9 plus 49 is going to be new summation of d square is going to be 122.7. And now if I solve your new r, it is going to be 1 minus 6 into 122.7 upon 990 into 6 divided by 990, and then we minus it. Your r is going to be 0.2563, which can be 0.2563. Do we have it an option? Yeah, we have it. 0.26, which can be rounded up to 0.26. 256, right? So 256 can be written as 0.26, option number B. So very simple question. Just you have to keep the thing in mind. If you solve this part, if you understood this part, it is going to be very easier for you. So it is a very easy question. You just need the formula. The formula is the most important formula, the part in this question. And as I've already told you, there are very higher chances of question can be asked from what? Rank correlation coefficient. Spearman's rank correlation coefficient formula. One of the questions are expected questions. So let's see. Any more questions do I see? Now, the last part remaining is congruent deviation. The last part remaining is going to be congruent deviation. What we will do is, we'll see congruent deviation in the next lecture. We'll solve congruent deviation in the next lecture, and after completing the congruent deviation, we would be done with the correlation part. We would be done with what? We would be done with the correlation part. So after completing the congruent deviation, I'll also complete your MCQs of correlation in the next part itself. So in the next part is going to be important because we are covering the last regression remaining. The method remaining is congruent deviation, and after congruent deviation we'll be solving the multiple choice questions that we have, MCQs that we have related to our correlation chapter. Once it is done, the next lecture is going to be the last lecture for correlation, and then in the next lecture, the day after, we are going to start with the regression. And regression, most probably it would be of 2 to 3 lectures only. So yeah, it is not going to be very lengthy or something like that. It is also going to be short. Okay, so that's it from my side. It is we'll end up over here, we'll sum up over here. Until then, see you in the next lecture. Keep studying. See you in the next lecture. Do share this video with all your friends. And yes, do let me know in the comment section, how did you find the lectures? Is the lecture helpful to you? Did you find the lecture? Yeah, do